Hello everyone, welcome back. I'm Eduardo, a physics and astronomy teacher, and in today's video we will be solving a set of quadratic equation exercises. If you've watched the previous videos explaining how to solve these equations, you can pause at the beginning of each solution and try to solve it on your own. Then press play and compare your results. Let's start by solving the first equation, 9x equals 6x squared. First, let's set the equation to 0 by subtracting 9x from both sides. Then we can rewrite the equation switching the sides. 6x squared minus 9x equals 0. Next, we need to factor out the greatest common factor. In this case, the greatest common factor is 3x. Then the second factor is 2x minus 3. So the factored equation is 3x times 2x minus 3 equals 0. Now, according to the no factor law, we set each factor to 0 and solve for x. 3x equals 0 or 2x minus 3 equals 0. Let's solve the first equation. Dividing both sides by 3, we have x equals 0. This is the first solution. Now let's solve the second equation. Adding 3 to both sides, we have 2x equals 3. Then we divide both sides by 2. We have x equals 3 over 2. So the solutions to the equation 9x equals 6x squared are x equals 0 and x equals 3 over 2. Okay, now let's solve the equation 2x squared minus 13x minus 7 equals 0. This is not a perfect square equation because neither the first term nor the last term is a perfect square. So we need to factor the equation by splitting the middle term. Since the coefficient a is greater than 1, the middle term needs to be split in such a way that the product of their coefficients is equal to the product of the coefficients a and c, which is negative 14. Note that since the product is negative, the terms must have different signs. The correct split is minus 14x plus x. So let's rewrite the equation by substituting the middle term with these two terms. 2x squared minus 14x plus x minus 7 equals 0. Now we can proceed with factoring by grouping. First, we group the terms in pairs. 2x squared minus 14x plus x minus 7 equals 0. Next, we factor the first pair by writing 2x times x minus 7. Notice that one of the factors is equal to the second pair. This way we can factor the whole equation by writing x minus 7 times 2x plus 1 equals 0. Finally, we set each factor to 0 and solve the linear equations. To solve the first equation, we add 7 to both sides. Thus, we find the first solution, x equals 7. To solve the second equation, we first subtract 1 from each side of the equation and then divide both sides by 2. The second solution is x equals minus 1 over 2. Okay, now let's solve the equation 3x squared equals 16x plus 12. First, let's rewrite the quadratic equation in a standard form. To do that, we subtract both sides by 16x and 12. Then we can rewrite the equation as 3x squared minus 16x minus 12 equals 0. Note that, again, neither the first term nor the last term are perfect squares. So we need to proceed the factorization by splitting the middle term. Since the coefficient a is greater than 1, the product of the coefficients of the middle term must be equal the product of the coefficient a and c, which is, in this case, negative 36. Since a times c is negative, the terms of the middle term must have different signs. Note that we can split the middle term as minus 18x plus 2x. Substituting the middle term by these terms, we can rewrite the equation as 3x squared minus 18x plus 2x minus 12 equals 0. Now we factor by grouping. Group the terms in pairs. 3x squared minus 18x plus 2x minus 12 equals 0. Factor out the greatest common factor from each pair. 3x times x minus 6 plus 2 times x minus 6 equals 0. Now factor out the common binomial factor, x minus 6, and multiply by 3x plus 2 equals 0. This is the factored form of the equation. Now, according to the new factor law, if the product of two factors is 0, at least one of the factors must be 0. So we set each factor to 0 and solve for x. The first factor is x minus 6 equals 0, and the second is 3x plus 2 equals 0. Let's solve the first equation. X minus 6 equals 0. Add 6 to both sides, and then we have the first solution, x equals 6. Now let's solve the second equation. 3x plus 2 equals 0. First, subtract 2 from both sides. We have 3x equals minus 2. Then divide both sides by 3. And then we have x equals minus 2 over 3. This is the second solution. Okay, let's now solve a little more complex quadratic equation. First, let's expand the left side of the equation. The square of a binomial can be written as the squared of the first term plus 2 times the first term times the second term plus the square of the second term. So the equation becomes x squared plus 2x plus 1 equals 2x squared minus 5x plus 11. Next, we need to move all terms to one side of the equation to set it to 0. Let's subtract 2x squared minus 5x plus 11 from both sides. The left-hand side becomes x squared plus 2x plus 1 minus 2x squared plus 5x minus 11, and the right-hand side becomes 0. Now we can simplify the equation. X squared minus 2x squared equals negative x squared. 2x plus 5x becomes plus 7x, and 1 minus 11 becomes minus 10. Now let's multiply the equation by minus 1 to make the coefficient of x squared positive. The equation becomes x squared minus 7x plus 10 equals 0. Now we can proceed to the factorization procedure. Note that the coefficient a this time is equal to 1. It means that the product of the coefficients a and c is equal to the coefficient c. So we have to split the middle term into two terms such a way that their coefficients, the product of their coefficients, is equal to 10. Since the product of a and c is positive plus 10, we have to split the middle term into two terms with the same signal. Then we can split the middle term as minus x minus 6x, but the product of their coefficients won't be plus 10. We can split as minus 2x minus 5x, And note that the product of their coefficients is equal to plus 10. Then these are the terms that we're going to use. Rewriting the equation, substituting the middle term by the two terms, x squared minus 2x minus 5x plus 10 equals 0. Grouping the terms in pairs, we have x squared minus 2x plus minus 5x plus 10 equals 0. Factoring out the greatest common factor in both pairs, we have in the first pair x times x minus 2, and in the second pair minus 5 times x minus 2. Now we have a binomial as a common factor, x minus 2. Factoring it out, we have x minus 2 times x minus 5. So this is the factored form of the equation. To solve this equation, we apply the no factor law, which states that the first factor equals 0, x minus 2 equals 0, or x minus 5 equals 0. For the first equation, we add 2 to both sides, and we find the first solution, x equals 2. For the second equation, we add 5 to both sides, and we find the second solution, x equals 5. Okay, now let's solve our last equation. 2x minus 1 over x equals minus 1. First, let's move all terms to one side of the equation to set it to 0. We will add 1 to both sides. So the left-hand side becomes 2x minus 1 over x plus 1, and the right-hand side becomes 0. Next, we will multiply the entire equation by x to eliminate the fraction. X times 2x minus x times 1 over x plus x times 1 equals 0. Simplifying the equation, we have 2x squared minus 1 plus x equals 0. Now let's rearrange the equation in standard quadratic form. 2x squared plus x minus 1 equals 0. Now we need to factor the quadratic equation. Note that the coefficient a is greater than 1. Then we have to split the middle term into two terms in such a way that the product of their coefficients is equal to the coefficient a times the coefficient c. A times c equals minus 2. Since the result of this product is negative, the coefficients of the middle term must have different signs. So we can split the middle term into 2x minus x. Note that the product of their coefficients, 2 times minus 1, equals minus 2. Now we can rewrite the equation substituting the middle term by 2x minus x. We have 2x squared plus 2x minus x minus 1 equals 0. Then we group the terms into pairs. 2x squared plus 2x plus minus x minus 1 equals 0. Factor the greatest common factor in the first pair. We have 2x times x plus 1, and factoring the greatest common factor in the second pair, we have minus 1 times x plus 1. Now the binomial x plus 1 is the common factor in both terms. So we factor it out, and we have x plus 1 times 2x minus 1. This is the factored form of the equation. Now, applying the no factor law, we have that x plus 1 equals 0, or 2x minus 1 equals 0. Let's solve each equation. For the first equation, we subtract 1 from both sides, and we have the first solution, x equals minus 1. For the second equation, we add 1 to both sides. We have 2x equals 1. Then we divide both sides by 2. X equals 1 over 2.